All right, hope you're doing well. This will be a little recap on Unit 6. Try to hit both Topics 1 and Topics 2. So we'll just kind of get started here. Starting with a ratio, a little definition. Um, Ratio is a relationship between two amounts, and the most common ways we see those represented are comparing something as A to B, and it can be written, in this format with a colon. It could be, spelled out. Fraction is very common. We'll end up using the fraction quite a bit throughout this unit, which leads us to a proportion, which is essentially made up of two equal ratios. And so you could have a ratio, here's an example of 4 to 3. Well, 4 to 3 is the equivalent of 16 over 12. This is one of those things where you could reduce this. 4 goes into 16, it goes in there 4 times. 4 goes into 12, goes in there 3 times. So 4/3 is equal to 4/3. And then we get to that idea of a proportion if I'm looking at something like this, because there's that missing piece that we can solve for. So as we look down here at these next few examples, these are proportions, and what we're trying to do is solve for the missing variable. Something like A and B are maybe a little bit. These are probably the entry level. Solve the proportions. So your x times 15 gives you the 15x here. 6 times 4 gives you that 24. So that's something to kind of to look at. Um, and keep that in mind. Same thing here, 22 times y and 8 times 11. That's where the 22y equals 88 comes from. And then we just use our algebra skills from there. It gets a little bit more complex when you take a look at something like letter C. With this one, the 9 times r, that's pretty straightforward. But then what we have to remember is that this is all kind of grouped together, this r minus 10. So when I do this multiplication, I have to take 4 times r, and I have to take 4 times negative 10. That's where that 4n minus 40 comes from. Then from there, you're just going to see the algebra skills, subtract 4r from each side, simplify that, and then undo this multiplication of 5 by using division, which will lead us then to that negative 8. Letter D down here kind of gets maybe a little bit more complex. You could think of this a couple ways. A lot of times the easiest way is just go ahead and say, okay, 2 times x is 2x, do the distributive property. 2 times 3 is 6. And then it turns into just like what we did over here with letter C. 4 times 2x gives me 8x. 4 times 6 gives me 24. 5 times 5 gives me 25. Similar approach on E. On F, there wasn't really any distribution to do beforehand. You just have to be able to say, okay, 22 times x, and then 22 times 7. That's how we get that 22x plus 154. 15 times x, 15 times negative 9. That's how we get 15x minus 135. And really, these 6 problems in here, this is the bulk of what we're going to be setting up and then solving throughout this entire unit. So if we get the solving down pat, then really we can focus on, all right, how do I set this up? And then once I've got it set up, then the solving should kind of, be something hopefully that we're fairly confident in. We want to make sure that we've got a good, level of confidence here as we're solving just kind of the regular, proportion problems, if you will. I'm going to clear this off, and then we'll kind of take a look here at the next page with extended ratios. All right, here's the idea with an extended ratio. If I was buying a Gatorade, uh, one Gatorade pack, and then buying 2 boxes of fruit and then 3 gallons of milk, how would that change if I told you, hey, we're going to buy 2 Gatorade packs? Well, that would mean 2 Gatorade packs, and then that would mean 4 boxes of fruit snacks, and then that would mean 6 gallons of milk. So everything has to stay, in that same ratio. Because if you look at 2, 4, and 6, that simplifies to 1, 2, and 3. If you were to, try to write that in simplest terms. Same thing if I said, okay, 15 packs of Gatorade. Well, 15 packs of Gatorade, that would mean 30 boxes of fruit snacks, and that would mean 45 gallons of milk. So just kind of keeping those things in the same ratio. We can apply that to these problems right down here. So this first example really focuses on utilizing or recognizing a skill from first semester, which is that the three angles of a triangle add up to 180, and that's what we see listed right here. So that was our recognition as we go through that problem, is that the measures of the angles of a triangle, in this case, triangle DEF, those are guaranteed to have to add up to 180 degrees. And then the ratio of those angles is going to be 3 to 5 to 8. Well, up here, we just looked at an example where it was like, hey, if I wanted, 15 packs of Gatorade, I did 2 times 15 and I did 3 times 15. So they all get multiplied by 15, 1 times 15, 2 times 15, 3 times 15. What we're missing out here is that value to multiply by. So we can kind of just think of this as, okay, I'm going to multiply this by something, multiply this by something, multiply by this by something. It's all the same value. And then when I add those together, it has to give me 180 degrees. So I'm really just using x as my unknown in that case. And then I just combine like terms. 3x and 5x gives me 8x. 8x plus another 8x gives me 16x. And then I go ahead and solve. And then to find these angle measures right here, A, B, and C, I'm taking this 11.25 and I'm just plugging it back in. So it'd be 3 times 11.25, and then 5x, or 5 times 11.25, and then 8 times 11.25. That's kind of how we come up with those values there. All right. The next set of questions focuses on trying to break it up proportionally. So M breaks a segment into 1-to-1 ratio. So that would mean there'd have to be an equal number of segments. On this side, there's 1, 2, 3. In order to be a 1-to-1 ratio, that means those values have to be equal to each other. So this is 1, 2, 3 segments on the other side. So if I think of this as 3 to 3, that's the equivalent of a ratio that's 1 to 1. Over here, we want it to be 2 to 1. So that means twice as many segments on the left side as there are on the right side. So if I went with 1, 2, 3, 4, that leaves me with 2. 4 to 2, this is 2 times larger. So that's how I know I've got that in the right spot. The other extended ratio type of problem that you might see also draws from a first semester skill, which was kind of that segment addition postulate. We might have done that. It was maybe at the end of Unit 2 or the end of Unit 3 from first semester. And the idea here is this total distance, it tells us, is 32. So the whole length is 32. But then this is broken up into pieces that are in the ratio of 3 to 2 to 3. So if you think about it, somewhere on here is point N, and this ratio is a 3. Somewhere on here is O, so that's going to be a ratio of 2 for that length, and this is a ratio of 3. So I just follow the same approach as I did up above with that triangle sum example. I can just say, okay, 3x plus 2x plus 3x. That's going to give me 8x equals the total length of 32. And when I solve, that means I need to multiply each one of those values in the ratio by 4 so that I'd end up with that correct total distance. So there's 12, 8, and 12, and then it specifically asks for n to p. So here's n, and then I would go ahead and add 8 plus 12, and that gives me 20 to get the length from n to p. With this last example down here, finding point M on the line segment that's formed by these 2 points. One of the ways that sometimes I'll think through this is, your rise over run. So I could break this up just thinking up 1 and right 2, up 1, right 2, up 1, right 2. Well, how many times could I do that? 1, 2, 3, 4, 5 times. And I want it to be a 2 to 3 ratio. That means there has to be 2 segments on this side and 3 segments on that side. So if I think through it in those terms, then that allows me to locate point M, splitting this into a 2 to 3 ratio.